class, the first thing you need to do is you need to go to aplusstudents.com. You need to go to the website and you need to log in. Then you need to select math as your subject. This is a grade 10 lesson. And the topic for today is algebra review. Okay, we are going to revise and we're going to review the rules of algebra. Okay, I'll give you the chapter number and the lesson number. The chapter number is 1 and the lesson number is 1. So the chapter number is 1 and the lesson number is 1. Okay, the name of the chapter is ratio and proportions. Okay, so let's go to the chapter 1 and the lesson number 1. Grade 10 maths, chapter number 1, lesson number 1, ratios and proportions. Okay. So the question is over here is we would be looking at several ratios and we will see whether they have a proportion or not. Okay. For the first question that says either we select a yes or no. And the question says, does the ratios 11 upon 10, the question number 1, does the ratio 11 upon 10 has an 8 upon 5 have a proportion, right? So in order to determine whether the two ratios 11 upon 10, that is given as, I'll just write them down, 11 upon 10 and 8 upon 5, right? They form a proportion or not, right? See, what we can see is the denominators are 10 and 5. Okay, so what we would do is we would try to make the denominators common. We would try to make them as the same denominator. So what we can do is we can multiply this by 1. If we multiply the denominator by 1, we multiply the numerator by 1. In order to make 5 a 10, we multiply it by 2 and we multiply this by 2, right? So what we can say is 11 upon 10 and this becomes 16 upon 10, right? The denominator is 10. So we have to make the common denominators. So what do we see? Are they both equal? Do they have a proportion? Are they equal? No, they're not equal because one of the denominators is 11 and the other numerator is 11 and the other numerator is 16. So we say they are not equal. They do not form a proportion, right? So we say no, they do not have a proportion. They are unequal. Okay, so what exactly we are doing is we are comparing different fractions or different numbers and we are trying to see whether they are equal or not. Okay, do we agree on this? Okay, let's look at another example. Do the ratios, these two given ratios, they form, for question number 2, the question says, do they form a proportion? Yes or no? We'll keep both the options over here and then we'll try to find if yes or no. Okay, do they form a proportion? So we know that since both the fractions have a different denominator, right? So we copy the first number, that was 19 upon 20, and the second number was 2 upon 4, right? Can we make a common denominator? In order to make a common denominator, that would be 20, right? 20 can be the common denominator. That means if we multiply this by 1, it stays, the denominator stays by 1. And for the second fraction, we can multiply it by 5. And we multiply it by 5. So we can say 19 upon 20. And the second value would be 2 times 5 is 10 upon 20. So are these values exactly the same? Are they equal? If they are equal, we leave as an equal. But we can see one of the numerator is 19 and the other numerator is 10. And both the denominators were same. So we say they are not equal. So no, they do not have a proportion. There is no proportion between them, right? Agreed? Do we agree on that? So what we are doing is we have two different fractional values and we are comparing the fraction values and we would see whether they are equal or not. Okay. Moving on to the next question. The next question says, do the ratios 4 upon 12 and 1 upon 3 have a proportion? For the next question, it says this, do they form a proportion? We have a yes or a no. We have two choices for question number 3. Let's see. If the first number given was 4 upon 12 and the second number given was 1 upon 3, right? What we can see is their denominators are different. So we would try to make a common denominator. But since 12 can be perfectly divided by a 3, so we can say that 12 multiplied by 1, then the numerator is multiplied by 1, 3 is multiplied by 4, this is multiplied by 4. What we can see is 4 upon 12, right? And this is 1 multiplied by 4 is 4 upon 12. So can we say both of these fractions are equal or they are unequal? Yes, they are equal, right? It comes out to be 4 upon 12 and 4 upon 12. That means 4 upon 12 and 1 upon 3, these two the numbers in fractional form, they do have a proportion. Yes, they are proportional to each other. That means they are exactly the same, right? Agreed? Okay. So we just need to make a common denominator. Okay. So moving ahead for the next question, it says half 1 upon 2 and 8 upon 16. Okay. Let's move ahead to question number 4. Let's see if they have a proportion. Okay. These two options and this over here. So if I would say, do they have a proportion? Question number 4. Let's copy down the numbers. 1 upon 2 and 8 upon 16. See, what we can do is we have two ways of doing it. We can reduce 8 upon 16 into 1 upon 2 as well, right? 8 times 1 is 8 and 8 times 2 is 16. But the easier way is to increase the number. Okay, so what we say is we multiply it by 8 to make it 16 and the numerator is multiplied by 1 and multiplied by 1. So 1 multiplied by 8 is 8, 2 multiplied by 8 is 16, whereas 8 multiplied by 1 stays as 8, 16 multiplied by 1 is 16. And we can say these two fraction values or 1 upon 2 would be equals to 8 upon 16, right? Yes, they do have a proportion. The given question, now the given fractions in the question have a proportion, even though their denominators were different. So what we did was we make their denominators equal and then we compare. Any questions up till now? Okay. Okay, let's move ahead. For the next given question, question number 5, the question says, do these two given, do these two given ratios have any proportion? Okay, we'll just compare. Let's realign this. Okay, if it's aligned, question number 5, do the ratios 1 upon 20 and 3 upon 4? So can we say this is 1 upon 20 and the other one was 3 upon 4? Can we make the denominator same? Yes, we can, because 20 can be perfectly divided by 4. That means when 4 is multiplied by 5, it becomes a 20. Whatever we multiply the denominator with, we multiply with the numerator, and we multiply by 1. That means 1 upon 20, and we have 3 times 5 is 15 upon 20. So do they have a proportion? See, since the denominators are already equal, we just need to compare the numerators. And we can say they are not equal. Do they form a proportion? No, they do not form a proportion. They are not proportional fractions, okay? Agreed? Okay. Let's have a look at one more question. Okay. Do the ratios 3 upon 10 and 4 upon 2 have a proportion? For question number 6, let me just realign this. Okay, we have realigned this. So does the question number 6, the numbers given in question number 6 that were 13 upon 10 and it was 4 upon 2, right? We can directly see that 4 upon 2 can be cancelled out, right? 4 upon 2 cancel out, it becomes 13 upon 10 would become, if we would want to see, we can say this is 1.3, this is 2, and they are not proportional, right? If we want to change these numbers into either decimal numbers, we can directly find the answer, because we know that whenever a number is divided by a 10, we put in a decimal number from the left side, right? And 4 divided by 2 is still 2. But let's see if we have to do all the working. Can we say, in order to make 2 as 10, we multiply it by 5, multiply it by 5, multiply by 1, and multiply by 1. So this comes out to be 13 upon 10, and this comes out to be 20 upon 10. The numerators are not equal, right? So we say, yes, they do not form a proportion. No, they are not forming a proportion. We could have done this question directly as well, just by changing into decimal and a whole number and compare them. Or we just make the denominator same for either of these fractions and then we compare. We can use multiple ways to solve a single question, okay? So moving on to the next question, if I would say, do the ratios 4 upon 3 and 20 upon 15, okay? Let's do it double times. Let's make something else out of this also. Yes or no? Okay. If this was the question given to us, I'll make 2 copies of this, okay? Why? Because I want to change this number over here. If I write this as 15 over 20, right? What I'm doing in question number 8 is I'm trying to flip the fraction. This is question number 8. This was given as 4 upon 3, 20 upon 15. What I did was in question number 8, I left 4 upon 3, but I flipped the fraction, 15 upon 20. So let's do question number 7 first. I'm just trying to see what a small change in a fraction value, flipping a fraction, what impact can it have on the question, right? So if the first number that was given to us was 4 upon 3 was compared to 20 over 15, right? We can multiply by 1 to leave it as a 15, the denominator, and 3 times 5 is 15, and times 5, right? So can we say 4 times 5 is 20 upon 15, and this would be 20 upon 15. Since both the fractions have the same value, we say yes, they do have a proportion, right? So we can say 4 upon 3 is equal to 20 upon 15, right? This is the statement that we can say, yes, they have a proportion. But for the question number 8, what we did was we changed one value. Okay, let's see now if they have a proportion or not. So if we say this was 4 upon 3 and the next number was 15 upon 20, right? So in this, okay, let's do one thing. Rather than 4 upon 3, because it's a decimal number, right? We are not doing decimals right now. Let's make this 3 over 4. Sorry. Let's make this 3 over 4 as well. 3 over 4, 15 upon. So if this is 3 over 4 and that is 15 upon 20, right? If I flip both the fractions, I'm doing this because it's easier for me to make a common denominator. If I would be using 3 and 20, then it would be 6.66 times, right? So that's multiplication with a decimal number. So if this is multiplied by 1, multiplied by 1, multiplied by 5, multiplied by 5, right? So can we say this is 15 upon 20? And this was 15 upon 20, right? And they're equal. So yes, they have a proportion in them. But I flipped both the fractions. Remember that. Okay? So different fractions can have different proportions. Okay? Let's see for the next question. 15. Okay. Okay. For question number 9, it says, this is our question number 9. I'll realign this and I would say yes or no. Okay. This is our question number 9. And what they are saying, asking us in question number 9 is 15 upon 10 the same as 3 over 2? We can multiply this denominator by 5, multiply the numerator by 5, multiply by 1, and we multiply by 1. So we can write this as 15 upon 10 and 15 upon 10, right? So we say, yes, they do have a proportion, right? So if this was the first way of solving it, let's look at another way of solving the same question. If I would say, if this is, I'll write an or over here. Or means we can do this way as well. If I would say the first number was given as 15 upon 10 and the second number was given as 3 over 2. Can 15 upon 10 be written as can they be written as 3 multiplied by 5 and 2 multiplied by 5? Right? And this was 3 over 2. When both the numerators and denominators are divided by the same number, we can remove that number and we can say 3 upon 2 is equal to 3 upon 2. So even if we reduce we increase the denominator or we reduce the fraction. In this case, what we did was we reduced the fraction, right? Even by reducing the fraction, we can simplify the question, okay? Okay. Let's look at the same question with an inverted values of, uh, let's see, I'll just copy the question. The same question I'm copying, I'm making it question number 10. What I will do is I will flip the fractions in this case, okay? And we'll see that if we are flipping the fraction, would it still stay the same? This was 15 upon 10. I'll write this as 10 upon 15. If I'm flipping both the fractions, okay? If this was 3 over 2, I made it 2 over 3. This was a new question, question number 10. What I'm trying to see is these two values, when flipped, both the fractions are flipped, would they still be in the same proportion? Because 15 upon 10 and 3 upon 2 were in proportion, right? They were equal. But if we flip both the fractions, that means the numerator becomes the denominator and the denominator is replaced by the numerator for both the fraction. Would it still be a proportion? Okay. So can we say 10 upon 15 and can we say 2 over 3? Can we multiply it by 5 to make the same denominator? Multiply by 1 times 1. 10 multiplied by 1 is 10. 15 multiplied by 1 is 15, right? 2 multiplied by 5 is 10. And 3 multiplied by 5 is 15. So we say that if we flip both the fractions, if the original question was in proportion and we flip both the fraction, then it still stays as a proportional to each other, right? They are in the same proportion to each other. Agreed? Okay, good. Any questions up till now? Okay, thank you. Okay, let's make some changes in the next question. What we are doing up till now is we are just comparing two values, right? Let's amend this. Let's try to see if we can do something else with this question. Okay. And okay, if I would introduce a new number over here, okay, if I would say 6 over 12. So now what we have is we have three numbers over here and we want to see whether these three numbers are in proportion. They all have to be in proportion, right? These proportions are also known as, see, in the previous case, 10 upon 15 was equal to 2 upon 3. These fractions can be called proportional to each other, or they are also known as equivalent fractions. Okay, they're also known as equivalent fractions. So we want to see whether these three fractions are equivalent or not. So 10 upon 20. Okay, the second one was 6 upon 12. And the last one was 1 upon 2, right? So for me to have a common denominator, what I would need to do is I would need to take the LCM, right? And that takes a lot of time. I would do a longer method right now, then I would show you how it's done through a very simple method, right? I'll show you the OR as well. So once you want to take an LCM, what we can do is we can write the denominators 20, 12, and 2, right? They can be divided by 2. This becomes 10, 6, and 1. They can still be divided by 2. This becomes 5, 3, and 1. We are trying to find the least common multiple of the denominators. Divide by 3, 5, 1, and 1. And the last one would be everything becomes 1. So we can say the least common multiple comes out to be 2 multiplied by 2 multiplied by 3 multiplied by 5. This is 4. This is 15. That means LCM comes out to be 60. So this means that each fraction over here needs to be changed into a common fraction, that is common denominator, that is 60, right? Every number needs to be changed to a 60. So 20 should be multiplied by 3, then the numerator multiplied by 3. 12 multiplied by 5, then the numerator multiplied by 5. 2 multiplied by 30, and 1 multiplied by 30. Agreed? 10 times 3 is 30. 6 times 5 is 30. 1 times 30 is 30, right? So we can see they all are equal. Yes, they have a proportion, right? This was the longer method which I showed you, right? So we can simply say 10 upon 20 is equal to 6 upon 12 is equals to 1 upon 2, right? They are equivalent fractions. But if we want to look at an alternate, okay, let's say alternate easier method, right? We would always want to have a easier method so that we can save our time. Time saving is also a very important factor while doing an examination. Okay, so if the first value was 10 over 20, the second value was 6 over 12, and the last value was 1 over 2. Can I write 10 over 20 as 2 multiplied by 5 and 2 multiplied by okay, right? 6 can be written as 2 multiplied by 3, whereas 12 can be written as 2 multiplied by 2 multiplied by 3, and 1 upon 2 can be written as 1 upon 2 only because they are already simplified. Can we cancel the values? 2 can be cancelled, 5 can be cancelled, we are left with 2 in the denominator. 2 is cancelled and 3 is cancelled, we are left with this. So can I say 1 upon 2 is left, 1 upon 2 is left, and 1 upon 2 is left, right? So this is by reducing the fractions. We can still say, yes, they are all equal and they have proportionality or they are equivalent fractions, right? So this was just the alternate way. So it's your choice. It would be your approach how you can do the question. Okay. Hi, Nahom. See, I did question number 11 in two different ways, right? So what I did was in the first type, I made the same denominator, but since there were three fractions, it is a lengthy work for us. So we try the easier way. We look at the alternate by reducing the numbers, right? So we reduce the numbers and we find the answer, okay? And they still are equivalent fractions. Okay. Moving ahead to the next one is 8 upon 14 and 4 upon 7 proportional to each other. Do they form a proportion? Let's see if they do. We have an option yes or no. Okay. So the question number 12 states this: 8 upon 14 and 4 upon 7, right? 7 is a smaller number. That means in order to make 7 a 14, we multiply by 2 times 2. This is times 1 and times 1. That means no change in 8 upon 14. And this becomes 4 times 2 is 8. 7 times 2 is 14. So we can say, yes, they are equal. They have a proportion. But final answer, we always write that 8 upon 12 is equal to the number given in the question. That was 4 upon 7. This is the final answer, right? Because these were the values that were given in the question, right? So we have to prove it through the values from the question. Okay. The next one we have is do the ratios 6 by 5. 6 by 5 means 6 upon 5. Okay. I'm just telling you my terminologies so that, okay, this is given to us. Let me reposition for more space. Okay. They say that question number 13. Do the ratios 6 upon 5 and 20 upon 15 form a proportion, or are they equivalent fractions? So if we say 6 upon 5 and 20 upon 15, right? So 15 is a larger number. That means 5 can be changed into a 15. 5 times 3, that means the numerator times 3 also. So 6 times 3 is 18 upon 15. And this was 20 upon 15. Are they equal? The denominators are equal, but the numerators are different, right? So we say no, they do not form a proportion, or they are not equivalent fractions. Okay, agreed? Any questions? Okay, good. Let's see the next one. They're saying that 18 upon 9. Okay, let's see. Do the fractions, sorry, form a proportion? Okay, that means we have these two fractions given to us. That is 18 upon 9 and 2 upon 1. So 18 upon 9, right? And 2 upon 1, right? So if we have 18 upon 9 and 2 upon 1, what can we say? See, the easiest way is to simplify. 18 upon 9 is equals to 2, right? Or if we want to do the lengthier method, we can say 18 upon 9, and this would also be 2 times 9 is 18, 1 times 9 is 9. And we say, yes, they are equal. That means for the final answer, we can say 18 upon 9 and 2 upon 1 are equivalent fractions, or they form a proportion. Agreed? Okay, good enough. Let's look at the next question. Okay, so do the ratios, given ratios, form a proportion? Let's see if they do. For question number 15, I would want you to do this question. Do they form a proportion? Can we have the answer, whether it's a yes or a no? This is question number 15, right? Can I be excused for just 10 seconds, right? Okay. Meanwhile, you do this, I'll be back. Yeah, I'm back. Thank you so much.
The question says, so what is the answer? Can we have the answer for this?
Do the ratios, this and this, form a proportion, right? So it says 15 upon 10, and the other one is given as 2 over 1, right? Can 15 be written, or simply we change it into same denominators? We multiply by 10, multiply by 10, multiply by 1, multiply by 1. So can we say 15 times 1 is 15, right? Upon 10, and 2 times 10 is 20 upon 10. And we can simply say that since the numerators are not, denominators might be same, right? But the numerators are different. So we can simply say that these two fractions are not equal. So the final statement would say 15 upon 10 and 2 upon 1 are are not equivalent. Okay, they're not equal, right? So we click on the no and we say that they're not equal, right? So next one we have is, we have the ratio that is given as, do the ratio 6 upon 12 and 1 upon 2. So for the next ratio that says, this is the given ratio, I'll just realign this. Okay, and they're asking us whether these ratios are proportional or not. Question number 16. Okay, so the first ratio we have is 6 upon 12, and the second ratio was 1 upon 2. Either we change the denominator like we did in the previous question, or we reduce the fraction value. We can write this as 2 times 3, right? 6. And 12 can be written as 4 times 3. That means 2 multiplied by 2 multiplied by 3. And this was simply compared to 1 upon 2. So if we have the same numerator and denominator, we cancel out. Same numerator, same denominator, we cancel out. Can we say, write this as 1 upon 2? And this was already 1 upon 2, right? So yes, we can say that they both are equal. Yes, they do have a proportion. That means 6 upon 12 and 1 upon 2 are equivalent fractions. Okay, so we have two types, two ways of doing a question, right? This could be done, we increase the denominator, or we reduce a number, right? These are the two possible ways how we can. Yes, thank you. Yes, it is a yes, because it is half and half. Okay, so we saw two different ways of doing one complete question. Okay, let's try to make, okay, this seems nice. The next question, do the ratios 2 upon 1 and 19 upon 3. Let's make, 19 is already a prime number, right? See, I'm giving you the answer sometimes so that when you are reading a question in your examinations, you should just, by reading the question, you should know that, oh, it's a prime number. So we cannot divide this by any other number, right? So let's see if 2 upon 1 and 19 upon 3. Can 19 be divided by 3? I don't think so. 19 cannot be divided by any other number. It's a prime number. And prime numbers are those numbers which can be only divided by themselves, or they can be divided by 1. So let's make this times 1 times 1 times 3 times 3. 2 times 3 is 6 over 3, and this was 19 over 3. We can directly say that no, they're not equal. For the final answer, we'll always write the values given in the question, okay? 2 upon 1 is not equal to 19 upon 3. They do not have a proportion or they are not equivalent fractions. Okay, good. Let's try a few questions from the test. Let's see if we understood. The options will be given to us. Okay. Okay, let me just go back to the website, algebra, ratios, proportions, and the test. Okay. Let's begin the test and let's see. Okay, this is question number 1 for the test. And the question number 1 says, do the ratios 4 upon 3 and 20 upon 15 form a proportion? Okay, this is the question given to us. We don't need a yes or no because we already have it in the options. Okay, so can we have the answer? Anyone? Do these two numbers that are fractional values 4 upon 3 and 20 upon 15, are they proportional to each other, or the same word would be, are these two fractions equivalent fractions? Yes or no? See, yes, there will be yes. Yes, that's right. Why? Because when we write 4 upon 3 and we write 20 over 15, we multiply this by 5 to make it 15, right? So 4 multiplied by 5, we can see this is 20 upon 15. That is equals to 20 upon 15, right? That means these two numbers given are, yes, they have a proportion. Agreed? Thank you. Let's move on to the next question. Okay. The next question says, very easy ones. I want to find a good, okay. The next question says, do the ratios 8 upon 18 and 1 upon 3 form a proportion? Okay, so let's put it down over here. Let's see, yes or no. Okay, this is our question number 2 from the test. So the numbers given are, sorry, I'll just copy down the numbers, 8 upon 18 and 1 upon 13. Can we see a prime number? Is 18 a prime or is 13 a prime? When we have 13 as a prime number, right? That means 13 cannot be broken down. It would be very rare that a prime number would, like, if only the fraction would be reversed. Prime numbers would be same when, like, 1 upon 5 and 5 upon 1. So we multiply by 5, sorry, we multiply by 1, we multiply by 5, we multiply by, see, it would be a very rare case. Let's not look at that. Let's look at this. So we cannot make the denominators common, right? We still can. What we do is we multiply this by 13 and we multiply the next fraction by 18, right? So 8 times 30. Yes, yes, it's a prime. Very nice. It's a prime, so it cannot be. I'm just showing it to you. 8 times 13, it becomes 104. We already know the answer. Thank you for giving me that answer. It's a prime, right? And 18 times 13 would be 234. 18 times 1 is 18 divided by 234. So they are not equal. We already know that because it's a prime number. No, no, we can still simplify. We can simplify, right? But they will not be equal. They are unequal, right? Because the prime number affects the value, okay? Your answer is perfectly right. Since it's a prime, It would not be, but we can simplify. What we did was we interchanged the denominators. The first fraction, that was 8 upon 18, is multiplied the second denominator, and 1 upon 30 we multiplied by the first denominator. Even if we made the denominator same, the numerator will never be equal because one of the numbers is a prime number. Okay? Your logic is perfectly correct. This one's a no because it's a prime. That is a perfect answer. Okay? So please do try the remaining questions. Okay? Okay, give it a try. Very easy. Just have some practice. Okay? Uh, Thank you so much for being there. Have a nice day and best of luck. Okay? Take care.